Hey guys, you are really going to enjoy this section. Solving rational equations. And what's the word rational mean? Fraction. Yay, fractions are our friends. So let's get right to it. Very first problem. If you were taking notes during class, I would save this and try to get you later with this little detail, but I'm going to write it right now. So hopefully you guys remember somewhere along the way that we learned that you cannot have 0 on the bottom of a fraction. So right off the bat, I'm going to take a peek down here and I'm going to say, hey, there is an x plus 2 down here. So if I were to plug negative 2 in for x, then I would get 0. I would have 3 over 0, and that's impossible. So the reason I'm pointing that out now is, let's say for the sake of argument that we solved this problem and our final answer was x equals 2. Well, that's a no-no, and you can't have it. So it is something that you have to at least look for. All right, it says in the box that if you're adding fractions, you got to have common denominators. So let's get to it. So the guy clear down here on the n has a 4, but I see that the first one has a 28. So I can go times 7, and I've got myself a 28. Whatever you do to the bottom, you must do to the top. The middle one does not have a 7, nor does he have a 4. So yes, I could have just skipped straight and said I need a 28 down there. So now the bottom one, or the first fraction, has a bottom of 28. The second one has a 28. The third one has a 28. But the middle one has an x plus 2, a binomial. Well, to fix it, it's just literally making it match. So if I put an x plus 2 with that first fraction, he now matches the second one. If I put an x plus 2 with the third fraction, he now matches the middle one as well. So check out all those denominators, even though it's kind of messy. They all have a 28. They all have an x plus 2. They're common. So way back at the beginning of school, we actually talked about some equations, some fraction equations, and when you had a common denominator, you got to just ignore them. So they're gone. All I have to do is worry about the top. So that's the good news with these. So if you look at this first fraction, I got a little distributive property to do. Done. If you look at the second fraction, I stuck a 28 in there. If you didn't know 3 times 28 was 84, you could certainly have picked up a calculator to do it. The third fraction, I'm going to times my 3 and 7 to get a 21, and then I'm going to do the distributive property just to save a little bit of room. So 21 times that x, 21 times that 2. And then it's just a matter of solving like normally. So this starts off kind of messy, kind of nasty, but ends up not being too bad. 9x, total these guys up, 102. How can I get the x's to one side? I could subtract the 9x over. That would give me a 12x and 42. My 2's are terrible. Well, move the 42. Subtract the 42 over. I got 60. Divide both sides by 12. And we got 5. So the answer is 5. Now, again, why was the restriction important? So way back at the beginning, we said that x couldn't equal negative 2, but I didn't get negative 2 for an answer, so that's okay. Final answer for that guy is 5. Moving along, I'm going to try to fit 3 problems in on this first video here. All right, let's fix this 2 minus y and y minus 2 first. They're not the same. The first fraction has a positive y, the second one has a negative y. The first one has a negative 2, the second one has a positive 2. We did talk about this as well. If I were to multiply that second fraction, and you could do this to the first fraction as well, by negative 1, let's see what happens. Perfectly legal, right, as long as I do the same thing to the top as I do to the bottom. So I'm going to go ahead and multiply the top. I got a 3 times negative 1, which is negative 3. So what would this negative 1 do to those guys? Well, it would make that positive 2 into a negative 2, and it would make that negative y into a positive y. And lo and behold, they match. Good news. 2/5 on the end. So the only thing that's keeping me from having common denominators, I'm going to change up colors here, is this guy in the n does not have a y minus 2, but he does now. And the other two fractions have a y minus 2, but they didn't have a 5. So if I stick a 5 in there for both of them, they match. Of course, the key is to remember to do the same thing to the top as you're doing to the bottom. So good news, I have common denominators. They all have 5s, they all have y minus 2s, which means I get to ignore them. First fraction, y times 5, done. Second fraction is 3 times 5, which is a 15. That's pretty obvious. But did you notice that there's now two negative signs here? There's the minus sign from the original problem, and there's the negative sign that we worked in there. So I got a plus now. Distribute on the end. I've almost got it. Subtract 2y from both sides. Subtract the 15 over. Divide by 3. Nowhere does it say these have to come out even. So if you want to go decimal, that's fine, but that would be a 0.3 repeating. Make sure you use the repeating sign. I'm going to leave it as a fraction. So you've got to be careful, though. Let's go back up to the original problem. Probably should have done this first. It said y minus 2. And this guy said 2 minus y. Either way you look at it, if you were to plug a 2 in there, I would have got 0 on the bottom, and that would have been a no-no. But I did not get 2 for an answer, so negative 19/3 is just fine. Third problem. Now, r plus 5, r minus 5, obviously not the same thing. I can't pull the same trick that I just did on the last problem. Try it. If you switch signs, that guy becomes a plus 5, which does match, but I would have to switch that sign as well, which would be a negative r, which does not match. So the only way I can fix this is to treat them like binomials. So I would say, all right, since the first one has an r plus 5 but not an r minus 5, I'll put one there. And I got it. The second one has an r minus 5 but not an r plus 5. So I'll put one there. And I got it. The third one doesn't have either. Bad news. He needs an r minus 5 and an r plus 5. Good news. We get to forget about the denominator. More bad news. The numerator is now a mess. Well, distributive property. I got 6r minus 30. Distributive property with that 6. I get 6r plus 30. Down on the end there. That's a little FOIL problem times 2. So in the interest of time, guys, I'm going to tell you it's 2r squared minus 50. So if you were to FOIL these two guys out, then times it by 2, you would get that. So quadratic equation, everything has to be on the same side for a quadratic equation. Let me clean this up. First, I get a 12r. The 30s would cancel conveniently. I get 2r squared minus 50 over here. But I need everything on one side if I'm going to do a quadratic equation. So I got 2r squared. I'm moving the 12r. I got the minus 50. Regular Algebra 2 students, I would like to tell you that this one factors, but I would be lying. It does not. So if you were given this problem and I wouldn't give this to you on a quiz, you would have to break out the formula, negative b plus or minus square root of b squared minus 4ac all over 2a, and do it by hand. If you are in my honors class, and that's what I'm going to do, they have a program that solves quadratic equations for them. So they could go ahead and substitute 2 in for A, negative 12 for B, negative 50 for C. And it would tell them that the answers are 8.8. They've been rounded, but that's what we had intended the program to do, and negative 2.8. So if you were to do the formula by hand, it'd be a heck of a lot messier. Hey, go back to the original problem real quick. Hopefully you notice that r couldn't be positive 5. And r could also not be negative 5 based on those parentheses that we had to start with. But we did not get that for an answer. Therefore, these two guys are acceptable, and they are, in fact, the answers. Wow, cut this one kind of close to 10 minutes. Thanks for watching. Check out part 2.